right, welcome to Living Answer Key. It's Stoichiometry Problems 3.5. We're going to be talking about molarity, and we're going to be talking about moles of a pure substance. So we've been doing a little bit of this later in some of the worksheets, but we're going to jump into it this time, making sure you can mix up both of these formulas. So we know if we are talking about moles of a pure substance, we're talking moles of a pure substance, we know we do mass over formula weight. Mass always has the unit of grams. Formula weight we can always get if we have a periodic table. So you want to make sure you have a periodic table with you. Okay, and a calculator fired up, ready to go. We know moles of a solution comes from multiplying the molarity, or the concentration of our solution, times the volume of our solution, but we know our volume has to be in liters. So I'd say read number one, take a look at, see if it's balanced, and see if you can't do this problem on your own, and then we'll get started together. All right, so first of all, it is balanced, and it says a student performs the following chemical reaction in order to determine the molarity of the nitric acid. So my question is, I want to know the molarity of my nitric acid over here. Okay, so molarity. And it says a student determines that they need 15.9 milliliters, and we like the liters better because we got to have it in liters. Okay, of our 0.2 molar NaOH to completely react with 0.0124 liters of a sample of nitric acid. What is the molarity? So that's our question. So the first thing you want to do is you want to get what you know and put it into moles. What do we know the most about? Well, we know the most about NaOH, so we're going to find moles of NaOH. So how we're going to find out how to put this into moles? You're going to take the molarity, which is 0.12, and you're going to multiply it by the volume in liters, which is 0.059. And when you plug that into your calculator, you're going to get 0.0019 moles of NaOH. Now, we did check and see it was balanced. Now we're going to do a coefficient ratio. This has a coefficient of 1. This also has a coefficient of 1. So we're going to say it's a 1-to-1 ratio. So we know we also have 0.0019 moles of our HNO3. Now, the question didn't ask how many moles of HNO3 we had. It asked the molarity of the HNO3. So what we're going to do is we're going to say, okay, I would like to know the molarity. I have the volume in liters. And then to solve for m, we divide this side by 0.0124. That cancels this out and leaves m by itself. So I divide this by 0.0124. And the answer is going to be 0.15 molar. Good. All right, I'd pause the program. I'd take a look at number 2. And then just see if you can figure it out. First of all, balance it. If you're thinking about what type of reaction it is, it's a combustion reaction. And remember, when you're balancing combustion reactions, you want to make sure you balance your C's and H's first. All right, pause it. All right, so hopefully you took a look at your C's, and so we put a 3 right here. And then our H's, so we put a 4 right here. And then I see I have 3 times 2 oxygens gives me 6, plus 4 is 10. So I'm going to put a 5 right here. Now let's read the question. How many grams of water? So here I want to know grams of water will be produced from 52.8 grams of C3H8 according to the following reaction. So now I'm looking here and I don't see a molarity, I don't see a volume. So if you're thinking about these two formulas up here at the top, which is the only one that we said works for grams, we're going to go back to our old formula here that we learned first, and we're going to do moles equal mass over formula weight. So whenever you see a Stoich problem, you want to see what can I put into grams. Okay, so I'm going to say moles of C3H8 is equal to the mass of C3H8. Hopefully you have a calculator and a periodic table. Go ahead and do 3 carbons and 8 oxygens for me. Formula weight is 44. And when you divide that, hopefully you got this number, 1.2 moles of C3H8. Now, the second step in any stoichiometry problem, after got moles, follow your coefficient ratio. This is a 1 to how many? 4. So I'm going to multiply this number by 4, and you're going to get 4.8 moles of water. Now, the question here is how many grams of water? So we know, again, moles equal mass over formula weight. So let's think about that. We're looking for mass, and the formula weight will be of what we want and what we have, which is H2O. So I'm going to do 16 and 1 and 1 gives me 18. When you multiply these two things together, you're looking at 86.4 grams of H2O. All right, I'd see if you pause the program, take a look, make sure you balance number 3, and give it a try. All right, with number 3, I see one sodium on this side, 2 sodiums on this side, so I'm going to put a 2 here. Now I see 2 hydrogens here, 2 hydrogens here, that gives me 4, so I'm going to put a 2 here. Oops, as I'm giving away answers here. Okay. Then I see, maybe I should underline it, then I see 2 carbons here, so I'm going to put a 2 here. And then I see how many oxygens? 2 times 3 is 6, plus 4 gives me 10 oxygens on this side. I have 4, and 2 gives me 6, plus these 4 give me 10 oxygens on either side. And then lastly, we have a sulfur and a sulfur. So we are all good to go with the balance. Now, if that's all you needed, pause it and try to answer the question. The question here says, what volume, so I want to know the volume of sulfuric acid, if it's 1.15 molar, would react with 21.6 grams of solid sodium bicarbonate, according to the following equation. So again, as you look at this, if you're lost on how to start, you want to make sure that you see what you can take and put into moles. So what we can put into moles, the only thing we put into moles is our sodium bicarbonate. So we're going to do moles of NaHCO3 is equal to the mass, which is 21.6, over the formula weight, which is 84. Okay, how do we get 84? 1 Na, 1 H, 1 C, and 3 O's. When you do that, you get 0.26 moles of your sodium bicarbonate. And then we're going to do our coefficient ratio. We're going from here, oopsie, sorry, to here. I don't know where I'm going. Okay, and this is a 2 to 1 coefficient ratio, 2 to 1. So my question is, I'm getting bigger or smaller? I'm getting smaller, so I want to divide it in half, and then we'll have 0.13 moles of H2SO4. Now I have moles of H2SO4, I have molarity of H2SO4, and I want to find volume. So I'm going to set this equal to M times volume in liters. What do we have? We have molarity, and we're looking for volume in liters. To get volume in liters by itself, I'm going to divide this by 1.15 to get rid of that. I'm going to divide this by 1.15. The number that comes out of your calculator should look like this, 0.0113. Now, you know you have to have a unit on the end of every answer. If it goes in as liters, it also comes out as liters. So this number is actually the amount of liters that we need to measure out, but usually we don't measure things out in class in liters, so we're going to change this by moving the decimal 3 times to 113 milliliters. As long as you have the appropriate unit on any of your measurements, I wouldn't take off. You just would want to make sure, okay, that you had liters for liters and milliliters for milliliters. Let's have you try number 4. Again, take a look and see if you need to balance it, and then try the problem. All right, so number 4 needs to be balanced with a good old 2 right there, and then we're good. And the question says, how many grams of CaSO4, that's this one, can be produced from 62.6 grams of K2SO4? So if you're thinking and you're kind of stuck here, what you're going to do is just a mass stoichiometry problem. You're going to use moles equal mass over formula weight the whole way through here. So what can we find out first? First, we can figure out the moles of K2SO4. If you just needed that to start, pause it and keep going. All right, so it means I'm going to take 62.6, I don't know why that's a 2, and then I'm going to divide it, okay, by the formula weight of 174. And when you do that division, you're going to do 0.36 moles of K2SO4. Then we have to do our coefficient ratio. If I know I'm going from here to here, this is a 1 to 1. So I also have 0.36 moles of CaSO4. Now the question wants to know grams, and I know moles equal mass over formula weight, so I'm going to do X over the formula weight of Ca, S, and 4 O's. When you look at that, that is 136. Again, moles, mass, formula weight, they all have to be the same if that's you're answering the question about CaSO4. When I say the same, I mean it has to be about CaSO4. So we're going to have this equal, when I multiply both sides by 136, 48.96 grams of CaSO4. All right, let's have you pause the program, try to balance and answer number 5. All right, to balance number 5, all I need is a 2 right here. And let's read the question. What mass of calcium, so here's my question mark, what mass of calcium would be needed to react with 51.8 milliliters, okay, and I'm going to change that to liters, of a 0.25 molar HCl solution according to the following chemical equation. So now, taking a look at this, what can you put into moles? Well, you should realize that this HCl is a solution, and I know that moles of a solution is equal to molarity times volume in liters, which I have both of those. So I'm going to find moles of HCl is equal to 0.25 times 0.0518, and when you do that, you're going to get 0.031 moles of HCl. Now let's talk about our coefficient ratio. We are going from here, okay, and people often get confused, from here to here. We are going from a 2 to 1, 2 to 1. So I'm going to divide by 2. And we're looking at 0.0065 moles of calcium. Now the question though asks what mass of calcium. So I'm going to set that equal to X over the formula weight of 1 calcium, which happens to be 40. When I multiply both sides, I get 0.26 grams of calcium is what would be needed to react with that amount of hydrochloric acid. All right, let's have you try number 6. Pause the program, balance it, and answer it. It's a 2-stepper. All right, so in order to balance this, we want a 2 here and a 2 here. Take a look. It says in the following chemical equation, what volume of 1.25 silver nitrate, molar silver nitrate, I want to know volume, question mark, is needed to react with 14.5 grams of NaCl. I don't know where that number is, so right here. Hopefully you got the hang of it now. As soon as you see a problem, you got to take what you can and put it into moles. We can put NaCl into moles, so I'm going to take the 14.5. I'm going to divide it by Na and Cl, which is 58. When you do that, you're going to get 0.25 moles of NaCl. Now let's talk about where we're going. We are here. We want to end up here. That is a 2 to 1. 2 to 1. I'm getting smaller, so I'm going to divide this by 2. When I do that, I keep my figures. I know that this is technically 3 sig figs, but just because we divide it in half, I don't know, I keep that. And now it said, though, we have a solution. I want to know what volume this is. So if you feel like you know, pause the program, go ahead. All right, I'm going to say the molarity times volume in liters. And then in order to solve for this, I'm going to divide this by 1.25 to get X by itself. So I'm going to divide this by 1.25. And then when you get that, the number that comes out of your calculator is 0.1. That's liters. Or you're more than welcome to make it say 100 liters. And it might say 0.106 or something, I think, is what you get in your calculator. That is absolutely acceptable as well if you're going to turn it into milliliters. Now, this question has a second part. It says, how many grams, or how many grams of AgCl2 can be produced from the same amount? So I could divide the same number by 58, or I can say, hey, I know I'm just going to start with that many moles of salt again, except for this time, I'm going to go from here, and I want to know how much AgCl2. Okay, so we're still doing a 2 to 1 ratio. Still going to take this and divide this by 2. But now I'm going to put it X, okay, here divided by 2. But now I want to know mass of AgCl. So I'm going to put X over, and hold on real fast. All right, X over the formula of AgCl2. So 1 silver, 2 chlorines. When you get that, you're at 178. Multiply them together, and you get 22.25 grams of AgCl2. All right, now we're on to the thinkers. Again, you're now looking at more test level ideas here. So what I would do is I'd make sure you pause the program, read the entire question, see if you can't start it, and only come back once you've given it a good try. All right, this thinker says ibuprofen is acidic and will react with a base such as sodium hydroxide. You can see that we have the acid and the base here. Oops. We can also, the following a chemical equation describes the double replacement reaction that can occur. The chemical reaction is balanced as written, so we don't have to worry about balancing it. We're going to assume it's balanced. And we're going to say a single 0.2 gram ibuprofen tablet, so I know that's how many grams, was dissolved in water. A student added 9.68 milliliters, and I don't like that number, so I'm definitely going to go 1, 2, 3, so you got to watch your zeros here. And that turns it into liters. Of a 0.1 molar NaOH. That solution consumed all of the ibuprofen. What is the formula weight of the solid ibuprofen? So when I'm looking here, the only thing I know enough of, because we don't know the formula for ibuprofen, usually when we have grams, we're fantastic and we can get moles, but this time it's a little different. It's a thinker. I do, though, have moles equal molarity times volume in liters of my base. So I'm going to find moles of NaOH is equal to the molarity of NaOH times my volume of NaOH. Now your calculator might give you something like this as 9.68, and it might say E negative 4. All that means is you have to move your decimal place 4 times that way. So the number you will end up getting is 0.000968 moles, and that's of my NaOH. Now, just like we would do before, we would do a coefficient ratio. I want to know more information about my ibuprofen, so I'm going to say this is a 1-to-1 ratio, so that's the same number of moles of ibuprofen that were in that reaction. Now, it has grams, and we want to know formula weight, so I'm going to put my amount of grams on top, and I'm going to put my formula weight on the bottom. Now, if you got this far and then you still got the wrong answer, that you probably just made a very simple mistake. A lot of people will leave X on the bottom. In order to solve for this, we can't leave X on the bottom. So all we're going to do is we're going to bring X up to this side and then make that equal, okay, over here. So I know that looks kind of interesting. So I'm going to rewrite this. So we have 0.000968X is equal to 0.2. Now you know how to solve for this. I'm going to divide this by 0.000968. Gets X by itself, 0.000968. Then, once we do that, you divide it, you're going to get a number of a formula weight of about 206.6. So the common things are to leave X on the bottom, and the other common thing is to not have enough zeros in your moles. All right, number 8, you want to make sure you get a periodic table and a polyatomic ion sheet in front of you here. I love this question. This could absolutely be one of the test questions on the test. So you have to pause the program and read it. And as soon as you start to feel like you might be able to get it as I'm going through it, I highly suggest that you stop and see if you can't finish it yourself. All right, so hopefully you guys are sitting here and saying, well, I don't know, I think I need an equation, and you absolutely need an equation. You need to write and balance a chemical equation in order to answer this. You got to do it on your own. It says you've been prepared to asked to prepare 18.4 grams of lithium carbonate. So that means you're going to find this number after the yield sign. So I'm going to put my lithium carbonate right here. That's something I'm going to make. This medication is used to treat depression. You have access to solid lithium chloride. Okay, so I have solid lithium chloride, and I also have a solution of 2 molar K2CO3. Okay, so I have a solid here, and this is a solution that's 0.2 molar. How many grams of LiCl2 and what volume of K2CO3 will be needed to prepare if I wanted 18.4, where's my number, grams of Li2CO3. Now you probably realize that we've lost potassium somewhere. I could have just said, hey, you do double replacement reaction, and you would know that lithium goes with the carbonate. So potassium has to go with the what? Chlorine. I know potassium is a +1, chlorine is a -1, so I'm going to make sure we write KCl over here. But then, before we can do anything else, even though we wrote it, we want to make sure it's balanced. So take a moment and try to balance that. I see 1 lithium, then I see 2 lithiums, so I'm going to put a 2 over here. And I see 2 potassiums, and I'm going to put a 2 over there, and then we got our 2 chlorines, and we're all good after that. If that's all you needed help with, I'd say pause it and see if you can't figure out from here. Alright, so what we're going to do now is we're going to take what we know the most about. We know we have a solid, but we don't know grams, so I can't do anything with that. We know potassium carbonate is a solution, but we don't know enough about that. But if we look at lithium carbonate, we know that we have 18.4 grams of that, so I can get how many moles of lithium carbonate I want. I'm going to divide that by 2 lithiums, 1 carbon, 3 oxygens, which is 74. When I do that, I do 0.25 moles of Li2CO3. Now, the only thing that's really different at this point is you're going to do 2 back calculations. We want to know how much of this solution, and then I also want to know how much of this solid. So I guess we'll do this one first. What is the coefficient ratio from here to here? I want to know how many moles of the potassium carbonate I'm going to need to make this amount. And this is a 1, oops, that's the wrong one. This is a 1-to-1 ratio, okay? And then that gets me a 1/4 mole of the potassium carbonate because it's 1-to-1. 1-to-1. Now, this is a solution. So which of these 2 formulas am I going to use if it's a solution? Absolutely, we're going to say we know the molarity. We're looking for the volume in liters. So I'm going to divide this by 2. And the number that we're going to get here is going to spit out in your calculator is going to be 0.125 liters, or you can say 125 milliliters of K2CO3. If you think you know how to finish it, pause it here and finish it out. The next thing I need to measure out is going to be going from lithium carbonate to lithium chloride. This is a 1-to-2 coefficient ratio, 1-to-2. So I'm going to double that. So I'm going to have a 1/2 mole of lithium chloride. This is a solid. So I'm going to do is equal to mass over formula weight, which is 42. And when I do that, I get 21 grams of lithium chloride. So if I mix this with this, I would get my target amount of lithium carbonate. Okay. Hopefully that worked. If you have any questions, bring them on into class.